Welcome back to a new video. In this video, we are going to talk about semantic search. We are going to use Facebook AI Similarity Search Vector Library, which we can also refer as FAISS. And we are going to talk about what is semantic search, how we can apply that in Python using LangChain, OpenAI embeddings, and FAISS. We are going to do examples with it. Let's start coding. I'm going to create a notebook for this video like notebook.ipmb. I'm going to be using VS Code, but you can use any code editor that you want. And in here, what I'm going to do is, I'm going to do my installs firstly. I have most of the libraries in my computer right now, but I'm going to do installation on the video. So I'm going to use, you can use pip. I'm on Mac and I need to use like pip3 install. We are going to need NumPy, LangChain community, and we are going to need pandas. And we also need OpenAI, but I'm not going to use that in this library set. I'm going to specify a version type for that because in later versions, I think after 1.0 version, some things in this code change. So what I'm going to do is I will say pip3 install and I'm going to specify OpenAI's version like this. And we can also do it in the way that we installed other libraries, but I just want to specify this. So you need to say pip install OpenAI equals to 0.28 for this tutorial to run smoothly if you are going to code with me in this video. Great. So with mentioning libraries and the codes working behind can change with time and updates. I'm going to select the kernel here, Python 3.11.4, and next step is going to be importing the pandas, and I will just read this data. For checking it out, I will say pd read csv and I will give this products.csv in here. Also, I'm going to store this inside something like, let's say data frame like this, and I'm going to call dataframe.head for checking my data. So we have ID in here, title in here, description in here, and we can see we have laptops, new MacBook Air features a stunning retina. Let's read the first description. So I will say data frame and I'm going to say index location, and I'm going to take the first one like this, and I'm not sure if I can see the description clearly from here. Yeah, I can see. Great. The new MacBook Air features a stunning retina display, Touch ID, and latest Apple designed keyboard, all in a thin and light iconic wedge design. So we can also check for the other ones, like I'm going to look for the Dell. It says the XPS 13 laptop has a 13.3 inch Infinite Edge display, powerful performance and ultra thin lightweight design. Okay, great. But as I know, we also have phones in this dataset, so I'm just going to expand this data.head a little bit, and yes, here we can see that we have a Asus ZenBook. So it's the ID 6, but in Python indexes start from 0, so we are going to enter 5 in here for reaching that. So I will do that, and we can see the Asus ZenBook 14 is a lightweight. I thought this was a phone, but it's a laptop. I'm really surprised. So we can find in the head, let's look for the tail with last 5 entries. I think we can find a phone in here. Yes, I'm 100% sure this is a phone, like BlackBerry K2. Okay, so I'm going to take this index in here. Same logic applies. The index number is 39, but ID is 40. ID starts with 1, index starts with 0. Okay, the K2 is a business smartphone with a 4.5 inch display, physical keyboard, and advanced security features. By the way, when I was young, I was using one of the Blackberries, and it was a really good phone. I remember it like that. But I think it's not selling on the market right now. I didn't see one for a time. Okay, so we have data about phones and laptops, their descriptions, and I'm going to say dataframe.shape, and we have 40 rows with 3 features. We have ID, title, description. Great. Let's check if we have any duplicates in our data quickly, like this, and we don't have any. Great. Now we can start. I want to start by defining the semantic search, and I'm going to write it like this. So semantic search is an advanced information retrieval technique that aims to understand the meaning and context of search queries rather than relying solely on exact keyword matches. By using techniques such as natural language processing and machine learning, semantic search systems analyze the semantic context of both the query and the documents. So I want to just write it, query and documents, like this. I want to mention it, and it converts them into numerical representations known as embeddings. These embeddings capture the underlying meanings and relationship between words. When a query is made, the system retrieves documents with embeddings that are semantically similar to the query's embedding, thereby providing more relevant and contextually appropriate results. This approach enhances search accuracy by considering synonyms, related concepts, and the overall context of the query. So, we can start to coding right now. We are going to start with data preparation, and this is a crucial first step for building semantic search system. So, we are in this phase, we are going to do cleaning and organizing our data. What we are going to do in this step is just going to call the data in here, and now I want to do some data processing on this column. Only this one is important. I'm going to convert all the text to lowercase and remove the extra spaces. Like one space is not a problem, but we have, like, let's say we have this A, two spaces B. I'm just going to delete them with the function that I'm going to define right now. So what I'm going to do is I will say define preprocess text, and I will give the text inside this function for sure. And let's write a comment about what it does. It's a good practice. Like I will say convert text to lowercase and remove extra spaces. So in here we are going to write our function like return. We are just going to return the text with lower and strip. This is the functionality we need. And in here what I'm going to do is I will say data description dot apply, and I will give the preprocessed text function in here, and it's going to return me series with the text type I want, the lowercase and without any extra spaces. And I'm going to save this series into data frame description column, and in this way I'm going to have my column updated. Like if I do it without this, like I'm going to call the data frame.head, it's not going to modify anything, like as you can see, and I'm going to make this run. This time I save my series, and we can see that the description column has changed. Great. Now we are going to generate the embeddings. This is going to be a crucial step in transforming text data into a format that can be used in similarity search. So, embeddings are numerical representations that capture the semantic meaning of text, enabling us to measure the similarity between different pieces of text. Like imagine like the description word in here described something like this, and etc. So we are going to represent the text with numbers right now. I will say import OpenAI for this, and then I'm going to set OpenAI API key, and you can get your API key from the OpenAI website. I'm not going to give you the mine, and they provide a $5 free usage for first login, but I'm not sure if it can be used in this embedding models. But this video won't cost too much. I think it's going to be like 4 or 5 cents in my opinion. So you can easily generate one for free and enter yours from OpenAI's Playground website. I'm going to paste my API key, make this cell run, and then I'm going to start to re-recording. But you need to get your API key entered in here, and you need to make this run. See you in a second. Okay, I have my API key entered right now, and I will say define generate embeddings, and I will give the text in here, and then let's give it like texts, and I'm going to write the functionality of my function. I will say generate embeddings for a list of texts using OpenAI's API. Also, I need to write the all in uppercase letters. And now in the function, what I'm going to say is I will say response, and I will say OpenAI.embedding.create and I will give input as text. This is the text that we are going to give inside the function at the first place, and then I'm going to say model, and let's use the model of text embedding ADA 002, and we are going to return like embedding for embedding in response data like this, and this is going to be our function. And now I'm going to do data frame description to list, and this is going to return me something like this, a list in this way, and I will say texts is going to be equal to this. Actually we can name it differently, like we can say text, and I'm going to make it run. Now I'm going to say my embeddings, like generate embeddings. I'm going to use this function in here, and I will give texts in here, and it raised an error because it says incorrect API key provided. I'm just going to fix that in a second, and I'm going to make this run, and after that I'm going to re-record. I probably forget to say my API key when I was showing you. Okay, as I thought, I forgot to run that cell with my API key, and when I make it run, now it runs successfully. And let's call our embeddings. So our embeddings, as we can see, we have numbers displayed in here, and great. So we have a lot of numbers in here, and I'm not going to look all of them. So let's delete this cell up, or let's just clear the cell outputs. Okay, we have the embeddings in here. We are going to create a vector store as the next step. So we are going to examine how to create a vector store, which is essential for indexing and efficiently searching through our embeddings. And in here we are going to use FAISS, Facebook's AI similarity search, and this is a powerful library designed for this purpose, allowing us to handle large volumes of data effectively. I will say pip install FAISS CPU like this, and I'm going to install it in a second. And after we have this, we can just close in here, and then we can say import FAISS, and we are going to import numpy as emp, and then we are going to initialize FAISS index, like dimension is going to be length of the embeddings, and then I'm going to just show you the dimension in here, and then we are going to say index is going to be FAISS index flat L2 and dimension like this, and I'm going to call the index for showing you. We can see it says FAISS civic FAISS index flat L2 proxy of civic object of type this, and now what we are going to do is we are going to a function as add to vector store, and we are going to pass indexes and embeddings. So let's do that. I will say define add to vector store, and I will give embeddings with IDs in here, indexes also you can say in the data frame, like let me call you. So these values I will say like, let's define a functionality in here, add embeddings and their corresponding IDs to FAISS. Also we can write it like this. And now we will say index.add numpy.array embeddings. And next what we are going to do is we are going to make this run, and we are going to call this function as add to vector store, and we will give embeddings with data frame ID to list. Again, this one I'm not going to make it run in here. This one you can see it gives a list, and I'm going to make this run right now, and in here we added them with our function. Now we can query through our vector store. So at this stage we will explore querying the vector store, which is the process of searching for documents that are similar to a given query. This involves converting the query into an embedding and finding the closest matches in our FAISS index. So We first convert the user's query into an embedding using the same model we used for our data. This allows us to measure the similarity between the query and the stored embeddings. Let's do that. We are going to define a function as search, and it's going to be query. It's going to take query as an input, and we will say for the functionality, search for relevant documents based on a query. And then we are going to say query embedding is going to be, we are going to embed the query, generate embeddings, and we will give query and the first index of this, like that. And now we are going to do search in a FAISS vector store, like D and I is going to be index.search, and we will give numpy array. We will say query embedding, and we are going to set the k as 10, and this means search for top 10 nearest neighbors, and we are going to return matched documents like data frame ilog, and we will say I0 like this. And next we will say return matched documents like this. Actually there is a typo, and I'm going to make it run. I'm just checking the function with my eye quickly. Everything seems cool. I'm going to make it run, and if there is an error we can directly see when we are doing this. So let's set something like as query high performance laptop, and then actually there is a typo I just saw, matched like this. Now okay, query is high performance laptop, let's save it, and now I will say match documents is going to be search function in here, and I will give my query in here high performance laptop like this, and let's call match documents, and we can see we have some laptops. Great. So let's see if it's working smoothly. So we called for high performance laptop, and as I know these are all laptops, like it says laptop, 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 not laptop in here, but I know this is a laptop, and laptop in here. Great. And in the high performance side I know some of these laptops, but this one is a good one for high performance, and this one is also a good one, and it seems great. It seems like it's working really smoothly, and with this function we are querying through our documents and we are returning the relevant indexes. So let's do some examples in this way, and let's try our functions and our embeddings with different queries and see how they work. So let's create a query like affordable smartphone, and let's call match documents like search query like this, and let's print the match documents. So we can see, great, it's working really good. So we only have phones in here, and mid-range, high performance, and it seems great. So I see budget friendly in here in the Amazon Fire HD 10. Great. So let's create a query like high-end gaming laptop, and let's say match documents is going to be search query, and let's call match documents. So we get this. As a result, I'm just going to compare this with the high performance laptop. I think it returns a similar query, not the same because I'm just looking this index. It returned ID 21 in here. It didn't return, but they are similar, I think. Great. So let's do like query is going to be ultra thin notebook, and say matched documents is going to be search query, and I'm going to call the matched documents like this. And great, I know ZenBook is a light one. Also I'm using MacBook Air, and it's a light laptop, so all the results are looking on point and true. So let's query with something like query is going to be good camera, and I will say match documents is going to be search query, and I will call match documents. And we see iPhone, Nokia, it returned phones only. So from here we can say it's working really good. And let's call like query is going to be long battery time, and I will say match documents is going to be search query, and I will call the match documents. So we see that laptops turned out. Lastly, I'm going to do something like query is going to be HD screen like this, and I will say match documents, and I will give the query in here. Actually, there's a problem. Okay, I did it wrongly. I'm going to use my function like query, and I'm going to call the match documents like this. So we can see HD in here, and I think in here laptops, this is a laptop as I know, this is a phone, it's a tablet. Oh, we have tablets also. So let's do something like query, and let's say tablet, and then we are going to say match documents. I'm surprised, I didn't know we have tablets. I will say query, and I will call match documents, and we can see that we have iPad, Pixelbook Go, and Galaxy Tab. Oh, we have tablets in our dataset too. Great. So if we call tablets and phones, let's try it. Yes, we have a mixed list, so it's working smoothly. Great. Let's summarize the notebook and close the video. So I'm going to come to the upside. We import pandas, we read our CSV file, then at the semantic search side, what we do is we pre-process text firstly, then we use the pre-process text function that we defined, which clears the extra spaces and makes all the characters lowercase and set it to data frame description. Then we generate the embeddings using OpenAI embeddings, and we save them. Then we import Facebook AI similarity search. Then we set our index with the dimension we have. Then we add our embeddings to our vector store. And at next step, we are going to searching through our vector store like this. We say generate embeddings, index, search, match documents, and we do add of example like high performance laptops, affordable smartphone, high-end gaming laptop, and ultra thin notebook, long battery time. By the way, they all resulted clearly. HD screen, tablet and phones. And great. So this was all for the coding part of this video. Thanks for watching the video. I'm sharing data science and AI content on my channel, and I upload at least one video every week. You can subscribe for more. Also, I have a playlist about AI and LangChain. You can check that playlist from the cards of this video. Have a great day.